This is practice problem 4.3, and the problem here is to calculate the moment about point A. Point A is the pivot point due to the three forces that are shown. Okay, in this case we know the location of every force, so the first thing I will do is take that 30 kilonewton force at an angle of 28 degrees, and I will break it into its x and y components. Once again, we have a right triangle. 30 kilonewton is the hypotenuse, so the adjacent side is 30 times the cosine of 28 degrees, and that equals 26.488 kilonewtons. Next, this leg, which is the same as the force in the vertical direction, is 30 times the sine of 28 degrees, and that's 14.084 kilonewtons. So here's point A. And here's my T-shaped block arrangement. I now have four forces that I'm going to apply. 70 kilonewtons, 60 kilonewtons, 14.084 kilonewtons, and 26.488 kilonewtons. So let's begin. If I extend the 70 kilonewton line of force, it's the same as sliding that 70 kilonewton force until it is perpendicular to point A. Then from the problem statement, I know that distance is 1.5 meters. The moment due to that 70 kilonewton force, then, call that moment 1, is 1.5 meters times 70 kilonewtons. Even though the force is way up here, it has the same net effect as if that 70 kilonewtons was mounted directly 1.5 meters to the right of point A. This is 105 kilonewton meters. It's going clockwise, and I will make clockwise forces negative. That's a sign convention. Second force, 60 kilonewtons. And if I look at my problem statement, I can see that that 60 kilonewtons is 2.35 meters from point A. That's a 3. So my second moment is 2.35 times 60 kilonewtons. Again, clockwise, so that is 141 kilonewton meters. And again, because it's clockwise, I'll make it negative. One more time with the clockwise moments. My 14.084. And if I look at the problem statement, it tells me that this distance between point A is 1.7 meters. So the third moment is the same as if I'd located that 14 kilonewton force exactly 1.7 meters to the right of point A. So my third moment is 1.7, that's the distance, times the force 14,084. Again, it's going to be clockwise, so that will be 29.943. Kilonewton meters. I always draw the direction of the rotation just so I can keep track. And then finally, this 26.488, if I extend its line of force until it is perpendicular, this distance is 2.0 meters from point A. Okay, notice this fourth moment. Again, if I poke my finger down at the point of pivot point, the center of rotation, and push in the direction of the force, my paper is now rotating counterclockwise. So it's 2.0 times 26.488, and that equals 52.977 kilonewton meters. That's going counterclockwise. Now I simply add everything up, and I account for the signs. Negative 105, negative 141, negative 29.9, plus 52.97, and I get negative 216.977 kilonewton meters. Negative means clockwise. So my total moment about A, and I'll round this down, is negative 216.98 kilonewton meters, and that's clockwise. And I always draw the little arrow in so I know what direction is. And that is my final answer.